In this video, I want to talk about how to do a guard trace in a op-amp circuitry. I will take this op-amp LTC2063 for example, and a lot of features in this op-amp is perfectly. It's very good for the high impedance sensors. So the guard trace will be really critical in this kind of applications. We can talk about how to choose op-amp in the future videos and what these values really mean, which are more critical than others. And this is a typical application for this op-amp, and you can see it's for oxygen sensor for as an example here. Whatever you have an oxygen sensor or shear sensor or pitch sensor, something high impedance sensors, usually you have a very high resistors in the feedback loop. You probably will need a guard trace. If you're going down the datasheet for this op-amp, you actually can see a example of a guard trace. Okay, here's a circuit. It's very simple. You have a high impedance sensor. So you have a sensor. There's a voltage source, and with a very high internal resistance. Okay, you have a bias voltage, and also a feedback loop. So this node here, that's your high sensitivity, very high sensitive node. Okay, whatever current produced by this sensor cannot really go into the op-amp because of very low bias current. You have to force the current to go through this feedback resistor, produce output voltage here. That's how it works. And at the same time, because this is a very high impedance node, if you have a leakage from your circuit board, that leakage current will go through this resistor and produce the offset voltage, right? So that's why you need this guard trace, like this dashed line to guard. You want to guard this node, and you want to connect your guard trace into this non-inverting input, because by the op-amp principle, ideally there will be zero voltage difference between these two nodes, the plus and minus side, right? Here's the layout. You have very typical, this is your feedback resistor, this is the op-amp, and this is the sensor, and the bias voltage. So this your the inverting input, your sensitive node. So the guard trace is circle all these elements, components here, and connect to the non-inverting input. Okay, and I will show you how to do this in a real circuit. I just use this op-amp and make up this very simple circuitry. A little bit difference here. I use a MMCX connectors, so you can imagine you will connect whatever sensor into this connector, and we have a 2.5 volts bias voltage to the sensor, also to a non-inverting input here, the positive input for the op-amp, and the power rail is 0 to 5 volts, so you need a 2.5 volts reference voltage for the middle supply. And also have a large value feedback resistor and a capacitor, just for typically you need a capacitor. Maybe not. It depends. I mean, the value depends on your applications. So here, just just examples to stabilize the feedback loop. Okay. Okay, then I'll show you how to actually lay out this guard trace. Okay, and I'm using a CircuitStudio, which is a simplified version of Altium, but you can use your favorite layout software. So we have this small board, then we import this circuitry into this board here. Okay, so that's all the components I just imported, and so we can just place the components here. The connector, that's the connector go to your sensor, could be a oxygen sensor or photodiode or whatever sensors you need. And this is the op-amp. We have this decoupling capacitor. This can stay here, And is your feedback resistor. Put here, and the capacitor in the feedback loop. Okay. Just let's say let's change this designator. I can change the designator. Make it a little bit smaller. Let's change to 20 mil, 5 mil, something like that. Okay. Okay. Yeah, the layout is very straightforward. So you have connectors. Let's see. So this is pin 4 here. That's pin 4 here. That's your sensitive node. That's the node you want to guard. And pin 3, that's your reference voltage. So you want to guard trace connect to this. Okay. Basically, we just connect the lines. Connect here. Okay, connect to here. Okay. Connect this. So that's your feedback loop right here. And for the guard, we want to start from this node here. Connect to the connectors. So the connector have 4 contacts. So you can just, so remember, you want to make your guard trace go through over your okay. So you want to this. Let's make connect this way. Okay. So you know this node that's come from pin 4 with the op-amp, that's your sensitive node, is a very high impedance node that you want to guard. And this your guard trace, okay? And your signal input come from the sensor will come to here, okay? Now this guard, you connect to this pin 3, so that means because these two have this node and this node have same voltage, so there's no voltage difference. That means whatever the voltage difference happen across your board will not leak it inside this loop here, so will not leak inside this high impedance node and produce a voltage. That's the whole purpose of this guard. Okay, let's clean up here. And we can connect these two. We can connect the connect to this decoupling capacitor. And for example, you have a way go to the another play for the voltage. Some issues with the software. Just need a second. Okay, and the same you can lay out the ground here, and a via go to a seven layer, and ground connects in here. Via go to different second layers or different layers for the connection. It doesn't really important over here. Okay, so let's look what's the guard. Okay, that's the MMCX connectors and op-amp, the feedback elements here. Let's turn off the 3D. 3D, since you can see the guard trace right here, right? It's a guard trace. But if you have a solder mask over the guard trace, because solder mask has a not very low resistance, but have a relatively low resistance, cannot compare with air. So you basically, because the leakage current still can cross over from the solder mask. So for the guard trace, you have to remove the solder mask from, remove all the solder mask over these guards. Okay, how do you do that? Let's go back to 2D mode, and you go to a top solder mask layers. Or if you go to single layer mode, you can see that. Okay, that's the guard here. What you need to do is you use a you place a lie over over these guards. Let's overlap a little bit over this guard. Okay. Remember, solder mask layer is it's a negative layer. Okay, if you put something over the inner solder mask line like this, there will be no solder mask. Okay, let's remove solder mask. Okay, the top layers is like a top layer, it's signal layer, it's a positive layer, so you can just overlap a little bit. I mean, you get the idea. You can fine tune these overlaps. Okay. If I put a solder mask slice over that guard, and if you go to 3D mode, you can see that we remove the solder mask over the guard. Okay. Yeah. You should, I mean, for a connector like this, for a connector like J1, you have this is through-hole connector. You have both, top layer. It goes through the top layer and the bottom layer. So actually, you should really also guard the bottom layer too. Okay, just go to the bottom layer, connect the line like this. It just guards, I mean, ideally it should be also in the middle layer. If you have a multi-layer board, you just, guard everything from the middle layer. Same idea, go to the bottom overlay. Sorry, go to the bottom solder layers and place a line over that guard too. Okay, like so. Okay. And in the 3D mode, you can see this is the top layer, so you guard, and there's no solder mask. I mean, in reality, you will fine tune this solder mask or this line, so they will overlap very well, but it's okay, just for demo. So on the other layer, you can see that also just copper, no solder mask. Okay. Another thing I normally do, I'm not sure that actually make a difference. Let's go to the top overlay. I don't like have a Silkscreen across my guard, right? Because this yellow Silkscreen, but in reality it will be in white or other colors, depending on the manufacturer. But the Silkscreen, I will see it's a low impedance pass if it across the guard. So I would remove the Silkscreen part actually. Remove the Silkscreen which cross over the guards. You can double click and just uncheck this option, lock primitives, and just go there, delete the Silkscreen. Or you can just, draw a Silkscreen line. Let's see, draw a Silkscreen line like this. Right? Okay, so you get the idea. Same idea for this component. So you want to go here, uncheck that, and delete this Silkscreen here. Right. Delete that. Okay, and same idea here. I'm not going to do that, but you get the idea. Okay, so now go to 3D mode. Okay. It will be something like this, and you have your guard. So it's this guard is set to nodes. Make sure no leakage current can go through this guard and go to this sensitive node. So it's top layer, the bottom layer, and if you want to look at 3D, in 3D or something like that. Okay. Okay, hopefully this will help you to understand guard and how to do a guard. Thank you.